Good afternoon, everybody. This is our second lecture. This lecture we will concentrate on rock property. Actually, what is rock and what is the rock properties? Because in rock mechanics we need to know the behavior of rock in different conditions. In different condition means different stress condition, different thermal condition, different electrical signal condition. That is mostly geophysicists are dealing with. So before moving to that, we want to get a glimpse of what is rock. I am a mining engineer, so that is why we will deal with the rock that we generally mine: coal bearing strata, country rock, and different open pit and underground mines. So in India, majority of our reserve is coal, and coal have a bearing country rock is shale sandstone. So if we want to mine a coal mine, we need to know the behavior of coal, need to know the behavior of sandstone, need to know the behavior of shale, so that we can design accordingly. Because when you do mining, you need to erect a structure, new structure on rock. So you have to interact with the rock with machines, with drilling and blasting, with explosives, and numerical different mechanical procedures. So, very essential for our rock mechanics course is to know the rock. That is actually primary work for this task is done by the geologists. They collect rock, they detect rock, what type of rock it is, what type of possible behavior of the rock will be. So, the task is done generally by the geologists. Now, why we need to know the properties of rock? In mining, we need to erect, we have to build the underground excavation. This excavation may be used for nuclear waste disposal as well as for other waste material disposal. Not only that, underground space reserve. So, to build the underground space, underground excavation, you need to drill. So you need to have an idea about what is the hardness of the rock. When the drill bit will cut, what will be the performance of the drill bit, how much it will advance at a daily rate, how much, which type of explosive you will use, whether it is a hard rock or whether it is a soft rock, or the rock bearing strata have some presence of water. So based on that you will design. So that is why it is very important on which purpose you are going to use our rock mechanics. So based on that purpose, your different procedures will change. Second is in mining, generally majority of the ore is extracted by open pit mining and underground mining. Open pit mining is from the surface itself, you excavate the material using drilling, blasting technology and different mechanical procedures. Continuous mining is one of the surface miner is one of them in open pit. Continuous miner is in the underground, and there are different rock cutting instruments that is being used in underground as well as in open pit mining. Third is majority of the Himalayan region there is a problem of slope stability, slope hazards, and when we built a national highway along the high in the Himalayan range, we have to design the cut slope. So whether the cut slope will be stable or unstable, it is depends on your designer, how you blast it, how you design the slope. So for that also you need to know the mechanical behavior and response of rock under different conditions. And the last, I have already told you, the nuclear waste repository, that is very important study. Now it has been done by different countries to know the rock behavior under different temperature conditions, because rock behave differently in different temperature conditions. In mining, coal mining basically, what we do in these different procedure, basically we drill and blast and then mark the material and transport it to the surface. In that procedure, we need to design the gallery through which we approach the mineral, means path, road. So that gallery should have some amount of breadth, width, and have the height. So based on the rock behavior, rock characteristics, the design will be. We have already laid down different regulations that will dictate you what should be the size and shape, but that is basically based on the rock parameters. So to design an underground mine, you need to know the mechanical behavior, and that is why rock mechanics is very, very necessary in that condition also. Now, these are the aspects mining engineer deals with, and that is why they need to know the mechanical behavior of rock in different conditions for their urgency, for their requirement, and to fulfill the industry requirement. And we all know coal is basically supplied as the majority of the energy in our country. So that is why performance of the coal mines, production of the coal mines, efficiency of the coal mines, safety of the coal mines is very, very necessary in this aspect. And that aspect is basically rock mechanics will help you to design a cell. Now in this aspect, we now understood the requirement to know the properties of rock. But how to know? How to know the properties of rock? One of the lecture I heard a few years back, Professor Revartuk is giving lecture to the student, and he is given more emphasis on observation. He is telling, as a rock mechanical rock engineer, you need to build a relationship with the rock. You just observe with naked eye, with no any preconception. You just observe, because that observation is very, very important for rock. I will show you one picture. In mining, there is a general practice. Mining sardar, mining engineers carry a kind of rod. It is basically lathi made of wooden. Okay. When they are going through the path, they used to strike the wall, they used to strike the roof and feel the sound. Sound tells something about the rock. Not only rock behavior. Rock behavioral changes in different time. So observation is very, very important. Very, very important. Because in the first class you have already seen that rock behavior, when material is ductile or brittle, in brittle it is very difficult, but in ductile case, slowly and slowly it is deformed. So definitely there should be some amount of manifestation. So that manifestation may be in the form of sound wave. So some amount of creaking sound may come, and those are very good engineer, they can feel the sound. Yes, there is some cracking sound is going on, means there is some process of crack is there. Not only that, people used to, when they examine the wall of a mine gallery, by observing this, if this kind of rock, so there will be some spalling kind of material is coming, then they will predict, oh, so this pillar, this wall is already under stress condition. If it is not under stress condition, wall should be very smooth. So some amount of material, spall already, means this particular portion is under loading condition, heavily loaded condition, that rock cannot bear. So these are the observation is very, very fundamental one for the rock mechanics engineers. You need to develop that eye, that ears, to feel, to observe the different behavioral changes of the rock in different conditions. So that is why observation is very, very important in rock mechanics. Second is, so this observation will tell you something about the characteristics of the rock. Then you need to test, because this testing procedure is basically a tool to help you to know the characteristics of the rock. Generally, what we generally test in material in any case, we generally test the material. Suppose we test our blood to know whether my fever is due to some virus or some bacteria. So doctor is actually affirmative about that, and the test, yes, your fever is due to malaria. So that test is basically helping you to diagnose what is the problem. Similarly, for a rock test, scientific procedure will help you to know the internal properties of the rock. So this testing procedure should be very, very scientific. Means there should be some causal relation. Means anything should be related with the cause, its manifestation. So that scientific procedure should be very, very rigorous, reproducible. What I will test in this place, what I will test in Calcutta, both the test results should be same. So that scientific procedure is very important for this. And for this, throughout the globe, there is a uniformity of opinion. That is why the standard procedure been developed, and ISRM, ASTM is one of them. They provide you the manuals to test different condition of rock and different how you will test. What are the precautions? What are the care you will take? What are the care you will take? What are the precautions you have to take? And what are the limitation of those tests? So these standard will tell you about this. Another is for this particular approach. For last 30 years, few approaches been developed. One of the approach is physical modeling. Nowadays also it is little bit used, because this physical modeling is basically like that. We know the rock is comprised of different kind of discontinuity. Different kind of discontinuity. So when we collect a rock sample through a drill core, may not be, it is possible to catch all the discontinuity present in the rock mass. So what people used to do earlier, so they used to design a sample in the laboratory itself, artificially, with similar kind of material, and they used to orient the joint according to the theoretical perspective, what is the possibility, and they test it. And this kind of procedure was used for many years to know, to characterize the physical properties of rock and rocks. So it is also a very useful approach once upon a time, not now, because nowadays equivalent material modeling and synthetic material modeling have already come out. Different software is available. Earlier we used to use PFC. Nowadays Professor Gassi have introduced us, and we are going to purchase one software, that is Irazu. That will also help you to synthetically model the different behavior of rock. So this is one of the machines to test the point load. So this is the generally engineers always carry some rod in while they are visiting in underground cavern or in mines to test always whether we are moving through a safe zone or we are moving through a very susceptible zone. So sound will speak everything. Now to stress the observation, what actually observation, from the observation what engineering perception will get? Generally in rock, we have already learned that rock have underwent a different stages of stress and strain for long million of years. We do not know. We do not know. But some process have underwent to rock means there should be some amount of signature. Fossil is the kind of signature, that is, it will represent how many million years, what type of species was there. Similarly, this kind of orientation of this rock will give you an indication what kind of stress and strain have rock undergone. So the geologist's interpretation would be, yes, rock have undergone some amount of deformation. Which direction, they will find out, then based on that they will classify whether it is inclined, synclined, dike, fold, whatever. So the geologist's role is very, very important in rock mechanics. Geologists, mining engineers, civil engineers can play a collective role for the development of the rock mechanics. But what mining engineers and general engineers will do? They are basically looking after the magnitude and the direction. Because the direction is very important. Because when we erect a structure, the structure should be oriented in such a way that it will fall in a favorable zone. So, as an engineer, we are always looking after not only magnitude, also the direction. So, as an engineer, our geometrical conception should be very clear, 2D as well as 3D, so that we can visualize how rock block will behave in different orientation. So, this is very, very important from the observation part also, as from the engineering point of view also. So, the second point is I have already dealt with that. We have blue books, orange book from the ISRM to that they have laid down different testing manuals. We have the soft copy. If you are like, you can collect it. And tomorrow when we will go visit our laboratory, we will show you different testing methods, at least few. But in this testing, there are many controversies for many years. What should be the size of the samples? What kind of machines you will use? What should be the stiffness of the machine? Based on that, you will choose the rock and you will test the rock at that machine. What should be the ratio of the length is to that? So, there are lot of controversies for a long years, and we have finally come together with an uniform decision that okay, we will align, we will maintain L by D ratio greater than 2. So, these conclusions have taken a lot of time. So, experimental rock mechanics have played an important role to come to the conclusion what should be the ideal size to test the rock. So, all what we are learning actually, it is a result of the labor of for 40 years, 50 years of different peoples. So, in this aspect, in the rock mechanics, we have to determine, we have to estimate different parameters. And we know that rock is not only homogeneous, rock is not homogeneous. So, rock is anisotropic. So, as anisotropy increase in different direction, your different constraint is also increased. For a perfectly elastic, you have to determine only two constants, Young modulus and Poisson ratio is sufficient. For transversely isotropic, 5 elastic constant is sufficient. For orthotropic rock, 9 elastic constant you have to determine. For general anisotropic, 21 number of parameters you have to determine to characterize the rock. So you can understand, based on the isotropic and anisotropic regime change, you need to know more and you need to characterize more parameters. So your testing procedures should be such that they can determine all these kind of parameters, and that will answer your requirement. So one of the earlier approaches, what people do from the mineralogical conception, when they study the rock, they usually determine the strength of the rock, and they used to correlate whether the rock, suppose it is a iron rock, hematite. So whether the hematite have in the mineral composition, whether the mineral composition have some influence over the strength. So it is basically an correlation. It is basically an empirical approach. The constituent material have some influence on the strength of the rock. So whether the presence of silica have some role on the overall strength of the rock. People have found that there is some amount of good correlation between these mineralogical constituent and the strength of the rock. So this kind of empirical approach was used for many years in rock mechanics as well as by the geologists to classify the effect of different mineralogical constituents on the strength of the rock. But nowadays we use it very little, because nowadays lot of good machines have come out and we used to find out different characteristics of the rock directly. So to test a rock, you need different machines. To test a rock, you need different machines. Generally in our laboratory, we have UTS, 50 ton, most probably 50 ton. We have MTS, we have direct shear, we have hydrofracturing, some sample facility. We have some instrument for determining the in situ strength, and we have some few apparatus related to rock and soil, that is overburden characterization to determine the hydraulic conductivity, that is permeability, and few many. And in the rock excavation laboratory, we have different setup to determine the rock hardness and structure hardness, and to determine the behavior of rock under different P wave, S wave curve. We used to determine the elastic constant under P wave and S wave. So we have many facilities in our laboratory. A few we will illustrate tomorrow, and rest you can just have a visit. So generally in rock we mostly concentrate on rock, basically triaxial facility. To test a rock truly basically under some confining pressure, and we apply vertical load and we used to see the behavior of rock. So this facility required different improvement, because when you apply a rock under some vertical load, under some confining pressure, there is a possibility of dilatancy, possibility. So your test setup should be very precise, so that it can very accurately measure the amount of volume change. One. Second is whether you are actually concentrating on that already Professor Grassily have shown you what kind of fracture you are expecting, and after the observation what kind of fracture you have seen, whether it is actually correlating with your actual need or not. And then again you have to test repeatedly to find out and correct your doubts. So this triaxial facility is very, very important in rock, and we generally also test our uniaxial compressive strength of the rock to determine the uniaxial compressive strength. That is also very, very, very useful in rock for designing pillar site width is to length ratio, as well as the gallery. So in rock mechanics, generally two parameters we majorly use. One is uniaxial compressive strength, another is by the triaxial. What is? And in the last few days back, when I was talking with Professor Grassily, they are telling they have fabricated a true triaxial facility. Generally in our lab, what we have, it is Brazilian indirect tensile test setup. What we do, suppose this is a rock, we take a core of this, and the diameter is to height ratio is half, reverse, and we test in reverse direction. The cylindrical sample is like that. We test it by this method, and we try to observe what kind of crack is developed, and indirectly we corroborate what is the tensile strength, and it is also laid down in the ISLN procedure. And nowadays and one work I have seen, and it is published in 2016. They have also tried to fabricate a possible true triaxial tensile setup for the rock. So it is also very important, because one major problem for rock is very susceptible in tension. Rock cannot much load of the tensile. So generally earlier what we used to do in a Mohr Coulomb curve, the left side portion, that is the negative portion, we used to calculate that is the amount of tensile strength of the rock indirectly. Now in test, in laboratory test, what we get the result, basically different kind of curve we used to get. Stress versus strain. So stress versus strain curve basically represent a locus of behavior. So generally locus of behavior, we generally what we do in geometry, in coordinate geometry, we try to find out what is the rule of that point, how it is changing different space, x, y, z or x, y. Then if we can elaborate what is the equation of that curve, then the behavior is known. But for rock, this kind of locus is not uniform. We have already seen there are 5 to 7 stages. So at different stages, at different point of time, rock behave differently with different loading conditions. So that is very important to note. One. Second is, different theoretical approach is available. Theoretical approach, we know that rock should, if it is behave like that, then it is elastic. If the rock behave like this, then it is brittle. Rock, if it is behave like this, then it is ductile. Like that, we know. So mostly what we try to find from this curve, stress and strain curve, we try to fit that curve with this kind of classification. Whether my rock is in the brittle category, whether my rock is under ductile category, or so if it is ductile category, then for the design it is very good. Then for the design it is very good, because it will take much amount of load without any sudden failure. So for an engineer, ductile material is very, very helpful for the mining, basically. In the roof, if it is a brittle, then there is a pretty chance of failure. And not only that, it may not only due to the failure, many different mining consequences may come. Coal dust explosion, there are many. Due to huge amount of load, and there is some amount of temperature change, so devastation may occur in a mine. So we need to know what kind of behavior your rock is showing in different testing conditions. To ensure that, you need to take care very, very carefully how many samples you have tested, how many samples you tested, how you have tested, whether that sample population is sufficient for that amount of rock mass you are going to design. So amount of rock sample, amount of sample you have collected is very important. Few sample is not sufficient to categorize, to classify, to characterize whole mine. So you need to collect a large number of samples in different points. So grid size should be very small, so that you can characterize near to the field condition. So that is one. Second is, you need to take care in the in situ condition, you need to take care in the laboratory that soil material is maintained in situ condition. So that is the moisture is not lost. Third is, the surface, the top surface of the core should be very, very flat. That according to the standard ISRN procedures, that should be maintained. Sometimes what we do in the laboratory, we generally compromise with that. So due to that, different kind of failure is also observed in the top platen. Means some kind of crack is developed in the top platen also, means top of the rock. That is actually not representative. So to develop this kind of geometry, this kind of path, we need to take care many things in the laboratory. We have to take rigorously care about all this testing procedure that is laid down in the standards. that rock, what we have, I have already told you, the rock behave differently in different temperature condition. So this temperature condition is becoming very important when you go very deeper in the mine. Suppose for in the recently what we are experiencing in HZL in Rajasthan, it is a Ching mine. It is now working in 700 meter. They are planning to have more than 1000 and 1200 meter. They will go for. And we have earlier experience in Kolar Goldfield. It was 3.2 kilometers. So geothermal gradient play a very important role for those mines. Not only that, for those mines in Kolar Goldfield, they used to design a central AC plant because temperature is so huge, a man cannot work. So humid, so high temperature, man cannot work. So to bring the mining condition to a working condition, they used to plan a central AC. So at 3.2 kilometers, you can understand how much temperature play important role. So you need to characterize the rock in different conditions in the laboratory also to simulate actual condition, because at that particular condition maybe in 3.2 kilometer rock is under that temperature. So you need to have a very good idea how rock will behave at that temperature, and you already know the amount of stress can develop at that particular level. You know the overburden pressure, based on that you can design. So basically in the rock, we try to find out three parameters. One is compressive strength, another is tensile strength, and the third is shear strength. Shear strength is also very important in rock, and very important for the rock joint that will be dealt by Professor Tessie. Very important for joint. So this laboratory procedure, mechanical procedure in laboratory for testing the sample may not be sufficient to know the characteristics of the rock. So you need to take some other help. One of the kind of help is physical modeling. In physical modeling, I have already told earlier, people who used to get like this. Suppose you want to determine what could be the influence if my joint is oriented 30 degree, 32 degree, 33 degree, 35 degree, 40 degree, one joint set. If it is a multiple joint set, 2, 3, not only that, in the reverse ubiquitous joint set, joint is different direction or all direction. So getting that kind of rock in a field is very difficult. Getting that kind of rock, what you want to know, that what could be the rock behavior in different joint condition, it is very difficult to get that type of sample. To overcome that, engineers have fabricated a physical model. And near to the rock, they used to fabricate in cement manufacturing factory that kind of rock and different orientation of discontinuity they fabricate based upon the demand of the laboratory, and they prepare samples with different orientation of joints. This is one kind of physical modeling. Generally we did in our laboratory also, and our earlier researchers also have done on that. So the purpose is to pinpoint what would be the influence of joint in different orientation of the rock in the field. What you are testing in the laboratory, it is not rock, nor it is the joint actual joint. You are actually know from the laboratory, from the field, that joint orientation is like that. So you have artificially fabricated in the laboratory and tested with similar kind of material. And this kind of material, what they generally nearly to the rock, they have chosen and they reported this is the facility they developed. This is in our IIT Delhi, under Professor Rao. They have developed this kind of facility, and they try to know the behavior of the rock stress strain curve under different joint conditions. So this curve will tell you about the possible behavior if the rock have same kind of joint. So this physical model will help you in two ways. One is, without directly testing that kind of rock, that is you are going to face in the field, you are priorly, you have done test in the laboratory and you know what could be the possibility. So in that way, physical modeling will help you a great. But there are different problems in this testing procedures. Problem is whether we have accurately taken care of the material ratios, because you are not taking rock, you are taking some other material. You are not taking the real joint. You are taking artificial kind of joint, but orientation is same. So there are some questions, doubt, controversies, and nowadays it is also not very used technology used for characterizing the rock. So that is why the interpretation of this method is not sufficient to characterize the rock. So to overcome this, people have thought of equivalent material modeling. One of the best model, this kind of equivalent material modeling is for a mine. Suppose for a mine, we have nowadays we are working 250 meter or 300 meter. In general, have 400 meter open cast mines. So 400 meter open cast mines means 40 number of benches. 40 number of benches of 10 meter height. So if you visit the mine from the top, you will feel this kind of this kind of things, feeling is developed. Because I was there for 1 month in 2017. What I see, the hard rock strata in HZL, they maintain nicely the benches. The problem is, they found that they cannot go more than 400 meters. Then later on they switch over to underground mining, and now they are doing that. Now in equivalent material modeling, what actually earlier we used to do, in the laboratory we used to fabricate using plaster of Paris. Okay, and we know plaster of stiffness and the rock stiffness, so we generally reduce by scale all the parameters. Suppose 10 meter is the height of the bench, so we usually cut suppose 10 millimeter. 10 millimeter bench to 10 meter. Likewise, we used to design the mine. Then what we used to do, suppose there is a dumper movement, many dumpers will move. Then we used to give weight slowly and slowly. Static weight first, then we try to monitor what kind of deformation is developed in the bench. So you have already scaled down the parameters. Rock parameters will scale down to plaster of Paris, and the geometrical parameter is also scaled down to the actual prototype model what you have developed in the laboratory, and you testing what the possible kind of behavior is. So this kind of method have given some amount of good result initially. How? Suppose when the dumper is moving, dynamic load is applied. So where, at what type of crack or what type of failure is developed, that will hint you in actually in mine, in similar condition, that you will taken care of those benches. So in that aspect, this equivalent material modeling will help. In other way, in earlier what we do in perfect sheet we used to apply a hole. Okay, then we used to apply some amount of load on the board in the perpendicular direction as well as in the horizontal direction, and we test the perfect sheet in different light condition. So if the light in different light condition, if you study the perfect sheet, there will be different contour of the line, contour of the light. So different light will diffract differently. So from that also we can determine the contour plot of the stress distribution in an underground tunnel, earlier approaches in equivalent material modeling. So these also help a lot to advance the knowledge about the rock in rock mechanics. So these type of methods are also used for many years. Basically, plaster of Paris was used for many years to develop equivalent material model. And nowadays, what people are doing, they are very fantastic job. They are taking equivalent material modeling with the plaster of Paris as well as using the computational facility developed by different numerical methods, FE, FEM, DEM. They are simulating same type of material in computer. As well as they are also testing the material in different conditions in the laboratory. So they are now trying to correlate the behavior of the rock, the equivalent material they are fabricating in the laboratory and different testing behavior, and the synthetic material you have taken care of in the computer. And they are matching whether my material what I have choose, whether it is behaving in similar way or not. So this is the latest trend of the different rock mechanics group they are trying to do to characterize the rock. What the important observation about this is the advantage of this kind of things is you can artificially prepare sample with a defined amount of porosity in the laboratory very accurately, and you can test it in different instrument available in the laboratory whether that porosity is okay or not. Then you test it in the lab, as well as you develop same kind of material synthetically and simulate numerically and see the behavioral pattern, stress strain pattern of these two kinds and try to match. So this will help you a lot to predict about the internal behavior of the rock. So the outcome of this kind of procedure is you are in a better position to know priorly what could be the possible behavior of rock in different testing conditions. So the experimental approach of rock mechanics is to know the behavior of rock in different conditions, means you are pretty sure, yes, surely rock will behave like that. So for that, your testing procedures, your sample procedures, sample material constituent, sample different physical properties need to be taken care of very, very precisely in this kind of simulations, and that simulation will help you to generate the behavior of rock in different conditions. So the outcome is of this kind of procedure, you can precisely predict how actually the rock will behave and fail, and at what point they will fail precisely you can predict. So when the advancement of computational will be more, when the advancement of computational power will be more, you can generate synthetically in the laboratory whichever complexity possible, and lattice formation you will do, and you will try to formulate the behavior of rock at different conditions, what actually desired in your mind or in your underground space exploration. That is all. So if you have any question, you are invited. Yeah.
So I have a doubt. No, I am doing my PG in geotechnical engineering. So we will test. So in which
This file.
Yeah, so there is triaxial testing machine for testing the soil. So here also there is triaxial testing machine for the rock. So in soil we will measure the the pore water pressure of a particular soil. So that's and
Moisture content.
yeah, moisture content. Not moisture content, the pore water pressure.
Okay.
And the stress reduction will be due to the volume change of
Due to the
volume change of the
volume change.
volume change of the soil.
Okay.
And this volume change is due to the expulsion of pore water pressure.
Okay.
So here you are measuring the you are testing the rock sample. So how it is measured, like whether the strength is observed when the that particle is cracked, or how it is measured.
Actually, in our lab, what we see in a triaxial test, there will be a sound, bit sound when the rock is already there. So from that you will stop generally the machine to movement of the platen.
There is no measurement of deformation.
Yes, we measure. Deformation is there, but when we will stop our procedure, that is one indication in rock, one advantage. There is a dial gauge. We used to measure the deformation. We already feed the LVDT in our data logger. We used to usually take the note of all this data. All our students they used to take. So the procedure is similar, but the testing sample preparation is entirely different for rock and soil. So preparing
The deformation will be measured in terms of what?
millimeter.
Okay, length. Then I have read out what property gives more strength to the soil, whether it's a friction between the particle or
Or
the
a soil.
sorry, rock. Whether it is the friction between the particle or the composition of the particular rock. Which property gives more strength to the soil?
Which
Rock.
Huh? Please loudly speak first. Last question.
Last question. What property gives more strength to the rock? Whether it is the frictional angle, the friction of the soil particle, or the composition of a rock.
Okay, frictional properties are changing.
No, which property is giving more strength to a particular rock?
It talking about C and phi, no? C or phi, which one?
So phi is giving.
C and phi, no, you are talking about. For
C,
rock?
C is always giving you the higher part because basically C is basically giving you the bonding strength between different particles ultimately. So the C is very important for rock also.
Also your machine.
Yes. No, you don't see. You ask question.
I have read out about you have told about a modeling, physical modeling of you are mentioned that you can give the porosity of a particular soil
Yeah.
rock.
Yeah.
So how it is given to
They prepare the sample like that. Means what is happening in material grain size is very important. Selection of the material grain size is important to come out with a precise amount of porosity what you want in the sample. So grain size playing the role to give you the desired porosity what you are going to test in the laboratory for a synthetic material or physical material.
so for a plaster of Paris the grain size will be
No, not plaster of Paris. We generally use grain kind of materials. Grain kind of material for that. Plaster of Paris is basically for soil kind of modeling. We basically more use. And the plaster of Paris is very uniform. Grain size is very fine. It is kind of clay. Fine clay is also fine. So plaster of Paris was earlier used. Now it is not used. We have many facility related to the thing you are doing in soil in our laboratory also. That is related to the triaxial testing also, and only difference is setup is entirely different, but the sample preparation is very important in soil mechanics, soil triaxial test basically.
so in soil mechanics we measure the pore pressure.
before that, you have to prepare the sample. So that preparation of sample is very, very important. At OMC you have to prepare and different three times you have to do the things. You have to maintain whether it is a homogeneous layer been developed or not, whether any discontinuity is developed due to the testing preparation or not. So many precautions need to be taken care of in soil. Any other question? You?
You have mentioned that there is true triaxial test. So may I know the difference between the traditional triaxial test and true triaxial test? Whether they are both are same or different?
Both are different. True triaxial means what we in our test setup we used to do, sigma 2 and sigma 3 we kept equal. That is a traditional triaxial we used to do in our laboratory. Now people are thinking that these two quantities are not same. So that facility we do not have right now in our laboratory. So that is we have not tested. But people are trying to fabricate that kind of setup and already it is marketed, it is available. So sigma 2 and sigma 3 is not equal. So that is true triaxial. Means they are applying stress in three differentiation, three number of stress, sigma 1, sigma 2, sigma 3. But all our other calculation what you will do tomorrow, that is sigma 2 and sigma 3 is equal, that is the confining pressure for a cylindrical rock dressing. Most probably for a true triaxial setup, you should be block kind of sample should be there. Block and not cylindrical to apply sigma 2 and sigma 3 different. Anything else?
So when we look into this rock properties, so what degree of resistance do you put into the so from a geological point of view, you know, focus on mineralogy.
Yeah.
But if you say it was given the granites of India, no two granites are same. It's always granites of granites.
Yeah.
So in that condition, means like do we have any general classified norms for the granite? So we are just like each case is separate individual.
You tell me the purpose.
It's like for it is fully get down.
Okay.
And we are planning to make it on a cross-sectional granite. So we are planning to make do we have a standard procedure for that one or just input everything?
One very important procedure what we follow in this kind of procedure, we take large amount of sample. So sample size is very important. So from the sample size, if the statistical variance is above something, we generally classify that you need to take care of this. So you need to take care of more. So it is a different kind of rock you are going to face. So this is the generally we think. So that is why not only is granite, there are many kind of sandstone even. Sandstone have a characteristics of 50 to 100, 100 to 150 kind of MPa. This is the variance. So much variance, 5 times, 4 times. So for that it is very important to collect rock at close intervals to classify the rock. Generally what we do in the tunnel as well as in Mangal. There is also in our CMR it is laid down how many sample you have to test for a particular volume of rock you are going to excavate. So there is already standard procedure in mining. But tunnel is not coming under mining, so we have to check whether the standard is available or not. But statistical variance concept is there. If the all testing, suppose you have collected 10 number of sample, 50 number of sample, if the value is within the statistical limit, 95% or 90% confidence interval, then it is okay. Else you have to take care of the different. That is we follow. Anything else? Others? Okay. So take a 15 minutes break, then we will